Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 4 in the CORS module titled CORS Vulnerability with Internal Network Pivot Attack. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, go down, select the learning path, go down, select cross-origin resource sharing, and go down one more time, and select lab number 4 titled CORS Vulnerability with Internal Network Pivot Attack. Alright, let's get started. This website has an insecure CORS configuration in that it trusts all internal network origins. This lab requires multiple steps to complete. To solve the lab, craft some JavaScript to locate an endpoint on the local network, and this is the subnet we're working with on port 8080 that you can then use to identify and create a CORS-based attack to delete a user. The lab is solved when you delete the user Carlos. Okay, so the steps to complete the exercise is first we need to scan the local network on 192.168.0.0/24 and look for endpoints that have a web service running on port 8080, and then we're going to create a CORS-based attack to delete the Carlos user. Of course, in order for this to be completed, there's going to be multiple steps over here, so we'll change that when we're solving the exercise. There's also a note over here that tells us to prevent the Academy platform from being used to attack third parties. Our firewall blocks interactions between the labs and arbitrary external systems. To solve the lab, you must use the provided exploit server and/or burp collaborator's default public server. Okay, so in order to complete the exercise, we have to use Burp Suite Professional, and that's why I'm not going to be using the free version of Burp. So let's click on Access the Lab, and in the meantime, open up Burp Suite Professional. And what I'm going to do is I'm going to open this in another tab because sometimes it times out and I have to reopen it. So I'm going to keep it on this page over here. Okay, this looks good. Let's click Close. Next. Start Burp. And make this a little bit smaller. Set Foxy Proxy to send requests to Burp. So if we go to home right now, it should be intercepted in the proxy tab, and it is. Alright, perfect. Our setup looks good. Now, before we start solving the lab, there's two things that I'd like to mention. First is this is an expert lab, and so it will require some knowledge of how to script in JavaScript, and that'll become clear because we're going to have to write 4 different scripts in order to reach our end goal. And the second thing that I'd like to mention is that the instructions of the lab were a bit confusing to me when I first solved it. So this says this website has an insecure CORS configuration in that it trusts all internal network origins. So when I read that, I assumed that we're trying to exploit this site over here. However, after solving the exercise, it's clear to me that the website that we're trying to exploit is the one that we're going to look for in the local network. So whatever IP address that we find that is running a web service at port 8080, that's the one that has a CORS misconfiguration, and that's the one that we're going to use in order to delete the Carlos user. This is just a sample website that we're given. So as long as we understand that, let's start off with completing step number 1, which is to scan the local network at 192.168.0.0/24 for endpoints that have port 8080 open. So we're going to start by first initializing our HTML document, adding a script tag, and then adding a variable for our collaborator server. And the way we're going to get that is we're going to click on Burp Suite Professional, hit Burp Collaborator Client, and then copy to clipboard, add HTTP, and paste it. And let's do View, toggle Word Wrap, so that we could see everything in this screen. Alright, so the first thing that we want to do is we want to loop through this range of IP addresses in order to find which IP is running a web service on port 8080. So we need a for loop. And we're going to say let I is equal to 0. I is less than 256. And then I++, and we're saying 256 because we want to reach all the IP addresses up till 255. And then in the for loop, what we're going to do is we're going to attempt to fetch the URL. So http 192.168.0. whatever the value I is, and then add the port to it, so 8080. So what we're doing over here is we essentially have a for loop that first tries http 192.168.0.0 running on port 8080. If it doesn't find a web server there, it tries .1, and then it'll try .2, and then it'll try .3 up till .255. So we're trying the entire subnet over here. And then we're going to say fetch the response. So response.text. And when we fetch a response, if the response is of text value, then perform this action over here. Now, if we're able to fetch a response of the web server, that means that the web server has a misconfigured CORS rule. Because as we mentioned in previous labs and in the theory video, we said that you can't retrieve the response of websites unless the website has some CORS configuration that allows your origin to access its resources. And so if we're able to fetch a response of whatever IP address we're on, that means not only does it have a web service that is running on this IP address on port 8080, but two, it also has a CORS misconfiguration. So in order to prove that to ourselves, we need a way to verify that we did really fetch a request, because this is running on the internal network and we don't have access to the internal network. So what we're going to do is we're going to say fetch this URL over here, and if you get a response of text value from it, then ping the collaborator URL. So we're going to say collaborator URL and add the following to the URL collaborator. So we're going to say IP is equal to the IP address of the web server, which is 192.168.0. whatever I is. And then we also want to see the response code, because we're not sure what type of misconfiguration there is for CORS. So maybe it only allows us to access unauthenticated pages. If we're lucky, we might be able to even access authenticated pages. But we need to confirm that in some way, and we're going to do that by just appending the response to the collaborator URL. And if this does not make any sense, it'll make sense once we run the attack. So we're going to encode the response so that we don't end up getting any errors because of special characters. And this looks good. So over here, let's do this in a try clause. So we're going to say try. And I'm going to close it off over here. And because we have a try clause, I'm going to add a catch to it. And I'm not going to include anything in my catch clause. And the reason is because I don't care if it outputs an error. I can't see the error anyways because it's running within the internal network and I'm operating from an external perspective, so I'll never really see that error anyways. So this looks good. Let's save it and let's run the attack to see what kind of output we get. So if you go to the exploit server and paste it in body, hit store, and then before we deliver the exploit to the victim, let's look at our burp collaborator and change the poll time to 1 second. Okay, essentially what we're doing over here is we're uploading our malicious code to this web server over here. And what's going to happen when we deliver the exploit to the victim is that the victim is going to look at the web server. And although the web server does not contain any content, so the victim user can't really see anything, what's happening in the background is it's running this script and it's trying to identify which IP address in the internal network has a web server running on it. And once it finds that, it tries to obtain the response of the web server main page. And if we can get the response, that means there's a CORS misconfiguration in the web server itself. So let's hit deliver exploit to victim. And hopefully we get a ping back. And we do. Perfect. So you could see over here, we got a ping back to our collaborator server, and we can identify over here the IP address that gave us a ping back, which is 192.168.0.181. So let's copy that and add it over here. So we're going to say completed and paste the IP address over here, and it's running on port 8080. And then if we go back to collaborator, you could see over here the response of the code. So let's look at the response in order to determine what kind of CORS misconfiguration we're dealing with. So let's copy this. And it's encoded, so we're going to have to decode it. So let's go to decoder, paste it in here, and say decode as URL, and copy this entire item over here. Let's put it in a file on its own. And save it as an HTML document. We'll say request1.html. And let's add a dash over here. Hit save. And click on view and toggle word wrap so that we could see the entire thing. Okay, so it looks like over here we've got an HTML document. It says lab, not solved on it. And you could see over here we've got a home page, a my account page, and a form that performs a post method where you could log in to the application. Now this form takes in 3 parameters, so it takes in a CSRF parameter, it takes in a username parameter, and it takes in a password parameter. So from looking at the code, it looks like we have a site that looks something similar to this site over here. So this is available externally, but the site that we hit on the IP address 192.168.0.181 is running a similar site as this one, and we're really landing on this page over here. So that's good news in a way that the CORS misconfiguration exists because it's allowing our origin to access its site. However, the bad news is that we didn't actually land on an authenticated page. So we landed on an unauthenticated page, which is the login page. So what's likely happening over here is either 1, the user is not logged into the application and that's why we can't access an authenticated page, or 2, the web server is configured to allow all origins. However, it's not configured to pass credentials in the origin. And so when the browser of the victim user made this request over here, it didn't pass the user's cookies with the request, and therefore the application directed us to the login page. So this means we can't automatically try to delete the Carlos user because we don't have access to authenticated pages. So what we're going to do is we're going to add another step over here. So this step becomes step X, and we're going to add step number 2 over here, which is try to find an XSS vulnerability in the login page in order to bypass all the CORS restrictions. So if we find an XSS vulnerability, then the request that we're performing, which is our script, appears as if it's coming from the origin of the website itself, and therefore the request will pass through and we should be able to access authenticated pages. And so the first step right now is to find an XSS vulnerability. Once we find the XSS vulnerability, we're going to try to access an authenticated page. And then once we access the authenticated page, we're going to try and figure out how to delete the Carlos user. So to do that, we're going to save this first and then go to this script over here, which is to perform step number 2. And this one's going to be really similar to the first one. So first we've got our HTML tag, and then our script tag, and then the collaborator URL. And we'll take it from over here. And let's hit view, toggle word wrap, and fix this. Next, we need the URL of the website, which was in our notes document. So let's go to notes.txt and copy it from over here. And then what we're going to do is we're going to fetch this URL. And then we're going to parse the response. So response to response.text. And if the response is in text form, then we're going to try and ping our collaborator server again. So let's add the try clause and the catch clause as well, so that we don't forget it and we end up getting an error. And we're not going to add anything in the catch clause, just like before. Okay, so the first thing over here we're going to do is we're going to add an XSS vector. So usually in a real life scenario, what you would do is you would have access to a version of the application that you can install locally, and then you would attempt all the possible XSS vectors on it until you can build one that you know for sure works. And then once you have an XSS vector that works, and then you attempt to get the victim user to click on your website and thereby exploit the XSS vulnerability in the internal server. In this scenario over here, we don't actually have access to a sample application that functions the same way as the internal application, and I kind of wish that that was the case for this application over here. However, if you try to log into the application, let's say random, and then the password is also random, hit login, you get an internal server error in this application. So you can't really test it in order to determine what XSS vector works for the username field and what XSS vector works for the password field. So you really have to just build your script and keep testing different XSS vectors until they work. Now, I've done this before, and so I already know what XSS vector works. And so we're going to assume that we did try multiple XSS vectors until we reach the one that we're going to use right now. So it's going to be in the username field, and the XSS vector looks something like this. So we've got an image tag, and the source of the image is equal to our collaborator server. So it'll ping our collaborator server if there's an XSS vulnerability. And then we're going to add to the URL the string found XSS is equal to 1, and close off the image tag and add a semicolon. So essentially what we're doing over here is if an XSS vulnerability exists, then this will be viewed as HTML code instead of a string. And what's going to end up happening is it's going to include an image which has a source of the collaborator URL. So when the victim user visits the page, it'll attempt to access the source, and so it'll ping our collaborator URL. Now, we're already pinging the collaborator URL with step number 1 over here, so we want to make sure we identify whether we're pinging it because we found an IP address that is running a web service, or we're pinging it because we found an XSS vulnerability, and that's why we're adding the string over here, found XSS is equal to 1. And this way, if it does ping our server, we know it's because we found an XSS vulnerability. Okay, so next we need our login path. And that's going to be login, username. Username is equal to our XSS vector because we're trying to test the username field to see if it's vulnerable to XSS. So we're going to say encoded URI component and add our XSS vector. Next, we need to add the password. which will say just random. It doesn't really matter. And the CSRF token, which is equal to the token over here. So you could see over here, there's a CSRF token that is being passed in the login form. And so we need to be able to extract the token from the request and then use it in order to attempt to exploit the XSS vulnerability in the username field. So now in order to extract the CSRF token, we need to add some regex. And to do that, first let's hit home over here so that it doesn't time out. And then we're going to visit regex101.com. and use that in order to build our regex string. So let's copy this first and add the string over here because that's where we're trying to extract our CSRF token, and we're going to build our regular expression over here. Now it's important to note that if you're doing a real engagement, you don't want to upload your client's code online on the site regex101.com just in case it ever gets compromised. But in this case, it's just an exercise, and so it's okay to use an online site to do this. Okay, so the first thing that I'm going to do is look for the string CSRF, which is this one over here. And you could see there's a double quote over here, and then value equal to, and another double quote. So perfect. Now I'm matching on this string over here. Next, I'm going to say match on this substring that is in between the two double quotes. And we're not matching on anything over here because we haven't added anything yet in the two brackets. So we're going to say match on all the characters except for the double quote. So you could see over here, it's matching right now on the green line, which is just the CSRF token. So this is the regex string that we're looking for. Let's copy that and add it to our script. So in order to use regex, we're going to use the text.match function. And we need to add it in backslashes and put it right over here. And this looks good. So we're going to close it off. And then we're going to say location is equal to URL plus login path and add a semicolon. So what location does is it essentially gets the current page URL, and then it redirects the browser to the new page. And the new page over here is the URL of the application, which is this one over here, plus the login path. So essentially what it's redirecting the browser to is exploiting the XSS vulnerability in the username field. So this looks good. Let's copy it. First, let's save it and then copy it, and then test it out in our exploit server. So let's go down, hit store, and then go to collaborator client, go down one more time, and deliver the exploit to the victim user. So if we don't have any errors, we should be seeing a ping back. And we're running it every second, which means that we do have an error and we didn't get pinged back on our server. So let's see what error we're getting. And I already know what it is. So this over here is incorrect syntax. It really should be right over here. Let's save it again, and hopefully that's the only error that we have. Store and deliver exploit to victim. Okay, and we get a ping back. So you could see over here in request to collaborator, it pinged our collaborator URL and it appended this string over here telling it that it did find an XSS vulnerability in the username field. So step number 2 is complete. So if we go back to notes.txt, we'll say over here, completed, username field, vulnerable to XSS. Now, the next step we're going to do is we're going to use the XSS vulnerability in order to access an authenticated page. And when I say an authenticated page, what I mean is the admin page, because that's the one that's going to allow us to delete the Carlos user. So to do that, we're going to go to step number 2, copy this entire thing because it's going to be very similar. The only difference is going to be our XSS vector. So let's close this over here, close request 1, and step number 1, we don't need it anymore, and start working with step number 3. Hit view, and then toggle word wrap so that we could see everything. And the only thing that we're going to change is the XSS vector. So let's delete all of this. And we're going to use an iframe in order to retrieve the content of the admin page. So we're going to say iframe source is equal to admin, and we're going to say onload. We've got new image dot src is equal to the collaborator URL. So it pings our collaborator URL, and then it appends the code of the admin page on it. So code is equal to plus encoded URI component, and it's this dot content window dot document dot body dot inner HTML. Okay, so let's see if we've got any errors over here. And it looks good, so I'm going to say there's no errors. So what's going to end up happening over here is instead of just getting a ping back telling us that the username is vulnerable to XSS, we're actually going to exploit that XSS vulnerability in order to obtain the response page of the admin URL. Now, at this point, we don't really care about CORS rules or the same origin policy because this is an XSS vulnerability. So it's running from the origin of the website. And so it no longer needs to abide by the CORS rules because it's running from the exact origin of the site that is hosting the admin page. So let's copy that and test it in our web server, in our exploit server. So let's remove it over here. Hit store and then deliver exploit to victim. And again, if we didn't have any errors, we should be seeing a ping back. However, we don't get a ping back, which means that we do have an error. And just to confirm, let's click pull now, and we don't get a ping back. So there's an error in here, and we need to figure out what it is. And I know what it is. We're missing a double quote over here. Okay, so this should close out the username field. So hopefully that's the only error. Let's copy it again, paste it in here. Hit store, and then click on deliver exploit to victim. And we still don't get a ping back. So we still have an error in our code. And I'm not sure what it is. So let's just remove the spaces over here. Although I doubt that's the issue. Let's copy it. See if that fixes things. Deliver exploit to victim. And yeah, I didn't think that would fix things. So I know for sure the error is not in any of these because we only copied it, which means that the error is in the XSS vector. Alright, I paused the video to figure out what's wrong and I couldn't figure it out, so I just tried it again and it worked. So I'm not sure why it wasn't working the first time around, considering that I didn't change anything. So let's just copy this one more time. And go to our burp collaborator client. We're on number 7 right now. Hit store. And then deliver exploit to victim. And we should be seeing a pingback, which is number 8 over here. So if you could see request to collaborator over here, you could see that we did get a pingback and we got the code of the admin page. So let's copy that. And add it in decoder in order to decode it. Let's copy it. And then click on File, New File. Save it in here. And name the file. And name the file request2.html. And let's look at it. Okay, so we've got an admin page. Let's hit view and toggle word wrap so that we could see everything properly. So we're definitely on an authenticated page because we can see /admin and you could see the ID of the account is the administrator. And you could see over here that there is another login form which performs a post request in order to delete users. So this takes in a CSRF token, it takes in a username, and then when you click on the submit button, it deletes that user. So that's essentially what we're going to do in order to perform our last step, which is to delete XSS vulnerability to delete the Carlos user. So let's mark this one as completed. And start working on step number 4. So for step number 4, we're going to save this one and just copy this entire script and paste it in here. Hit view, toggle word wrap, and make changes to this over here. So let's delete this entire thing. And instead, in onload, we're going to add a variable var f is equal to this dot content window dot document dot forms 0. So we're grabbing the first form. And then we're saying if you can see the username field, then f.username.value is equal to the Carlos user. So we're essentially setting the username to Carlos, and then we're saying f.submit, and that should be it. So what we're doing over here, and there's a mistake. Okay, so what we're doing over here is we're essentially looking for the form, which is this one over here. So this form over here, and that's the only form that is on the page. And then we're filling the username field with the string Carlos, and then we're hitting the submit button in order to delete the user. So let's save this over here. Now notice we don't ping our collaborator URL anymore, because if we do successfully delete the Carlos user, we should be able to see a message over here pop up that says you've successfully completed the exercise. So let's delete this. Hit store. And then deliver exploit to victim. And here we go. we see congratulations, you solved the lab. Alright, so we successfully completed the exercise by performing 4 steps. The first step was to scan the local network in order to find an IP address that is running a web service on port 8080. Once we found that IP address, we attempted to look for XSS vulnerabilities in the parameters that are available on the page, and we found an XSS vulnerability in the username field. Now, once we found an XSS vulnerability in the username field, we exploited it in order to request the content of the admin page. Once we analyzed the content of the admin page, we saw that we can submit a form in order to delete the Carlos user, and so we used it to delete the Carlos user. This by far has to be the most involved lab and probably the hardest lab that I covered in my videos so far. And this concludes the course module.